Professor Elvis, thank you for accepting our invitation and welcome to Space Month, Cambridge. Professor Elvis is joining us today from Massachusetts. Before we begin, I'd like to introduce you to our audience in case they aren't familiar with your work. Dr. Martin Elvis is an astrophysicist at the Center for Astrophysics, Harvard and Smithsonian, and an expert on the supermassive black holes we see as quasars. Concerned about the future of astronomy, he has turned to research on asteroid mining, covering both technical and legal policy issues. Asteroid 9283 Martin Elvis is named after him. He's the author of the book, Asteroids: How Love, Fear, and Greed Will Determine Our Future in Space, published by Yale University Press in 2021. Once again, welcome, Professor Elvis. Before I begin, I must ask you, Professor, how does it feel to have an asteroid named after you? And what is the process of having an asteroid named after you?
It's a very mysterious process, and it's great fun. No, as I relate in my book, I got asked by a well-known asteroid person who was a scientist who was at CFA, Center for Astrophysics at the time, what my birth year was.
Okay.
And it's like, do I have to admit to that? And then she said, don't worry, it's perfectly harmless. This won't go to. And it turns out they need to make it absolutely unambiguous who it's named after. They include your birth year in the naming process somehow. So I won't tell you that. So then I had no idea what it's for. And about 6 months later, I was at this conference in Helsinki in Finland. First time I'd been to one about asteroids, comets, and meteorites, and they have this wonderful banquet where the wine flows freely. And I was sitting with all the grad students because that was my level. I was a beginner in the field. And at the end, they started announcing people's asteroids. And, oh, wow, what a great idea. I was applauding and applauding for all because one by one, all the new PhDs got their asteroid, right? It's like, and then they said, Martin Elvis, and I was like, wow. I had no idea. It was great fun. Yes, I probably wouldn't have had quite so much wine if I'd known. So.
It sounds really, really fun.
It was, yes. It's like being a made man in the mafia, except without the homicide.
That's a good analogy. So my first question is actually related to your book. So I got a chance to read a few chapters of your new book. And I was really intrigued by this chapter titled Making Space Safe for Capitalism. It actually reminded me of this BBC podcast by Professor Martin Sweeting, where he was talking about the innovation of nano satellites back in the 1980s when it was a relatively new concept. He said that in the beginning and of the initiation process of the nano satellites, he was glad to not have a lot of investors on board, because once investors get on board, they want 5 times the return of the capital they invested in a very short period of time. Do you think the pressure of investment and the return on investment stifles the process of innovation, especially with respect to asteroid mining, where profitability may take up to decades, if not centuries? In this situation, do you think government funding would be more suitable compared to private funding?
Yeah, it's not one or the other, but I'm a great fan of Mariana Mazzucato, who is a UCL, I think, professor of economics, who pointed out in her first book that most of if you take your Apple iPhone, most of the technology in it was government-funded development, and that the genius, of course, of Steve Jobs was to put it together in this appealing package and make it something you can't live without. But it was building entirely on government-based research. So I think it's a very normal progression that you start with government investment for long term, and then when the risk has come down to a certain level that the venture capitalists and their friends can tolerate that risk, then they start investing. So there's a lot probably that has to be done first by government in various ways. And it's not just technology. That chapter is mostly about regulation and policy issues, all sorts of things that will need to be settled. The most important is for a asteroid miner is, can you have any mining rights, any mineral rights on an asteroid, right? And at the moment, the answer is absolutely not.
Absolutely. I felt like the mining right question is a little distant in the future, since you're still trying to figure out how to get there and what will we do with those resources. But it actually leads me to my second question, because you're talking about mining rights. So we constantly hear whenever I'm listening to a podcast by a space entrepreneur, they're always talking about the abundant resources in space, and they're always saying this enough for everybody, so we won't have the same situation that we have on Earth. However, you mention in your book and the same chapter that even though resources in the universe are vast, they're concentrated in small number of locations, making only a tiny fraction of them accessible, and highly concentrated resources always lead to high competition.
Mm-hmm.
In light of this, and when space mining becomes evident, we will need some sort of regulation and rules. Do you think the onus of making such regulation lies simply on the governments and space lawyers, or like the policy analysts? Or do you think the scientific community must also participate in it, since they are the only one who can achieve the technical feat of sending the mission to the asteroid?
I think that's large. The problems with mining space resources, either the asteroids or the moon, which are the only two real candidates for now, are not really technical, not really scientifically technical. It's not finding out new ways to do things, to make rockets or something. It's making them work, making them cheap, and sending them out to do the prospecting, and then learning how to deal with objects like asteroids, which are very cold, probably made of, have no gravity, are made of aggregates of rock, rubble piles, they're called. So that, and those behave very strangely. So there's a bit of fundamental physics there, but it's mostly engineering. So there's no, I don't think there's any really new physics needs to be put in there, for instance. Unless, of course, we manage to get some of the attempts to get fusion rockets working actually pay off. But I think that's a bit of a long-term, hope rather than a realistic thing in the short term. But I'm talking mostly over the next 10 to 20 years, where I think there'll be a lot of preparation by government-sponsored surveys for asteroids. And then there will also be a growth in a market for asteroid material, which will be in orbit. And then once that market exists and we've learned where all the resources are, that would be the time when people could start mining those resources. Should scientists be involved, however, from policy points of view? I think so. We were all, as astronomers, taken flat-footed by the Starlink and other low Earth orbit constellations, making it very hard to observe the sky in some cases. And we don't want that to happen again. So, for instance, a very obvious place that I'm doing a little work on now is the far side of the moon is the only place we can make a cosmology telescope to look at the time before there were stars or galaxies. And because you've got 2,000 kilometers or more of rock height blocking the radio signal coming from Earth, so you're on the far side. There are very few places on the far side which are actually big and flat to put a telescope like that, because it has to be an array of antennae that are probably 200 kilometers across in the ultimate incarnation of this. And we'd better find that out, which ones, where we want to put that, and make sure that that becomes a radio quiet zone, that people don't set up other installations for mining, say, nearby. One of the places where it could be where you could put this array, this cosmology telescope, would be in Mare Moscoviensis, which is just on the far side of the moon. But that's also one of the places with a particular concentration of helium-3, which some people want to mine from the moon for putting in fusion reactors. We don't have those fusion reactors yet, but let's think ahead. We really want to hope to arrange that mining and mining and astronomy just don't go together, right? They interfere with each other terribly. So we want to make sure that maybe that, or maybe another one of a very small number of places on the far side of the moon is set aside as a science preserve. The same would be true of some very cold craters on the moon, for instance, where you could do various kinds of, you could do infrared astronomy, but you could also perhaps do cold atom physics and things like that, which would be on a uniquely large scale. So we need to find out seriously where those best places are and try to get an international agreement that they will be left for science.
Absolutely. I always feel that when governments and policy analysts come together, they often miss out the science bit of space, which I feel is the entirety of space. So we end up making laws that may not be absolutely practical or may not account for the interest of all. And especially with space mining, when you have competing interests of capitalist economy, and then you have interests of astronomers and lawyers and the general community, you would want to involve all of them in that process.
Yeah, I think perhaps quite a number of your audience will be immediately reacting against this making space safe for capitalism. They say, well, we don't want to do that.
I had that reaction too. I'm not going to lie. That
right,
line
and
me.
so I think I should defend my choice there, and that is my book is all about how greed is a very useful tool. So long as we keep it as a tool and not let it master us, that would be fine. Because the profit motive brings costs down, brings price down. It's particularly good at that. It's particularly bad at other things, of course, in environmental destruction and so on. But the only way we're going to explore the solar system at scale is to bring the cost down immensely. And the same is true of the big telescopes I would love to see in orbit, far bigger than what we have now. And if we don't do that, I think at least our golden age of astrophysics will grind to a halt, and planetary exploration will chug along at this 1 or 2 missions per decade, the level that it's been at forever. Instead, we should be looking at things 10 times the number of missions and 10 times bigger telescopes. And that, I think, it will be enabled because capitalism will bring down the price of doing things in space and give us, we have very limited capabilities in space right now. You can't build a telescope in space. You have to, like James Webb, you send it up, it's all built and it has to sort of unfold like origami. Yeah. And so that's very limiting and very expensive. And I think we can overcome all that, and science will benefit greatly from the use of space resources.
So you would say it's a necessary evil.
Sorry?
You would say capitalism, yeah, is a necessary evil.
Capitalism needs regulation. It doesn't work without regulation, and the level of regulation we decide to impose will be a big question when it comes to handling space. And the problem now is that there are so many different players going to space, going to the moon particularly in the next 10 years, even 5 years, that it's going to get very difficult to negotiate. This isn't the USA versus the USSR anymore, like it was in the 1960s, when if they decided what the agreement was going to be, everybody else had to toe the line. Not anymore, right? So it gets a very difficult regime for policymakers to work with, and diplomats and so on. So it's going to be challenging.
So since we were talking about the moon, research suggests that moon will most likely be the first mining target. Mm-hmm. What challenges await us for mining the only natural satellite that we have?
Well, there are technical challenges, obviously. The moon has a lot of advantages compared with asteroids because it's always there and it's only 3 days flight away. And you can even operate things remotely because it's a 1 second delay each way between sending a signal from Earth and getting it to the moon, and then another second coming back. So if you have mining machines that are intelligent enough to predict even 10 seconds ahead, then you can operate remotely from the Earth even. And so those are great advantages. None of those apply to asteroids. Asteroids win because they have no gravity, virtually, microgravity. And so you pay a penalty by going down onto the moon because you then have to use a rocket to get back up, whereas you could almost jump off an asteroid. So you get a big energy advantage by going to the asteroids. So you go to the moon, and operating on the moon is tricky. There's a Lunar Surface Innovation Consortium that NASA is funding through the Applied Physics Lab of Johns Hopkins University. And I go to some of the sessions they talk about. They're worried about where do you get power to power your machines, your human base, if there's going to be one, or your mining operation. How do you operate in extreme cold? Because the places where there's most likely to be water are actually at only a few degrees above absolute zero, maybe 25, 50 degrees. They worry about dust. Dust is terrible stuff on the moon. It's very sharp, and if it gets into everything, it's very small, and it can rip spacesuits and so on. And and certainly get into your machinery. So there's that sort of technical challenge too. Then there are the things you alluded to, where because a lot of people are going to the few places where the resources are concentrated, there will be lots of scope for conflict at various levels, and there is no very good way of resolving those conflicts right now. And of course, we hope they stay as somewhat friendly, or at least peaceful conflicts. But we have to think about how we're going to resolve those conflicts.
From an astronomer's point of view, since Moon is our only natural satellite, what can go wrong if our mining mission ended up disastrously?
Well, I don't think it's going to. The moon is very big compared with any mining operation we can put in place in the next, I would say, 100 years, probably, certainly several decades. So it's not going to like change the orbit of the moon or blow the moon up or anything like that, which would be a poor thing. That would not be good. The sort of things I would hate to see, for instance, would be I would personally dislike seeing any hint of human activity on the moon viewed from a night on the ground on the Earth. So some people, the helium-3 mining, for instance, would happen by strip mining the top few meters, couple of meters off or the lunar mare, and you would see those stripes, because it has to be hundreds of kilometers. Wow. To get enough helium. So I think that's a terrible idea. Some people might think, though, that if we had a settlement on the moon and you could see the bright lights of that from the Earth, they might find that inspiring. Yeah. And it's not obvious what the right answer is. I think many cultures, probably all cultures, revere the moon as an important object in their cosmology. So it would be, I suspect, on balance, a very poor idea to make anything visible.
Absolutely. So my next question is, if I understand it correctly, the Kardashev scale is a method to measure a civilization's technological advancement based on the energy it uses. Mm-hmm. It illustrates different types of civilization, and each type indicates the civilization's ability to use and store the energy either on its planet, the planetary system, or the galaxy. Mm-hmm. The evolution from one type to another type would ensure the survival of the civilization in the long run. And I'm assuming asteroid mining is our attempt in utilizing the energy of our solar system in order to ensure the continuation of the human civilization. However, mining exercises will consume trillions of dollars before it makes an actual impact. It makes one wonder, could we be using our investment and time in a better exercise, like improving existing space technologies capable of fighting climate change or contributing towards carbon capture techniques on Earth?
Yes, that is the 3 levels of Kardashev civilization. It's amusing that there is already a limit on the type 3 galaxy wide civilization. No more than 1 in 100,000 galaxies has achieved that. And that's based on it's a real astronomical measurement. Wow. And there will soon be, I think they've got funding to do this now, there will soon be a limit on the number of type 2 civilizations where you enclose the entire star and capture all the radiation from the star. Then you glow in infrared light as a result. You can't hide that. There's no way around it. So these are people at Penn State in the US. I immediately forget their names. It's very unfair of me. I'm so sorry. And maybe I'll think of it in a moment and come back to it. Anyway, they have this way of putting a limit on it. So it will be very interesting. And of course, then planetary-wide use of that would be capturing all the sunlight, hitting the Earth and using it for whatever industry, staying alive. So I think Kardashev was doing this in like 1960, 1962, something like that. So the idea that there might be other limits that kick in before you can capture, or you can cover the entire Earth's surface with solar panels hadn't really occurred to anybody. But obviously we now know there are much stronger limits on how much energy we can use. Even if we replaced all fossil fuels and just use solar, then there's a limit to how much energy we can put in before we warm the planet. Now, it's a much bigger number than we use fossil fuels, but there is such a limit. So that's kind of interesting. There's always this argument about space where you could say, well, why don't we also do this or that, right?
Yeah.
So feed the hungry, etc. And it's not an either or question. We can do both. And certainly by a lot of our Earth observation work has led to a lot of good things like weather forecasts. So we know a hurricane is coming. A lot of the evidence for global warming comes from satellite observations. So it's already contributing, I would say. And the question was if you want, how much tax money do you want to put into this? And it's a tiny amount right now. It's a cup of coffee or something for every person on Earth. But if you make it so it's a profit-making enterprise to do something in space, then you aren't trying to get tax dollars. You're actually generating wealth that can be taxed and used for any purpose, including saving the world. Right, so it can contribute in that sense, like all economic activity. You can tax it.
Do you think asteroid mining has the capability of saving the planet?
Not in itself, perhaps, but there is a group called the Solar Sunshade Team or something, which I am slightly involved with, asking, could we cut down the amount of sunlight coming to the Earth by putting up a kind of umbrella in front of the Earth and blocking out 1.8% of the light. I think that's a excessively accurate number. I don't think we actually know how much sunlight we need to block to cool the Earth by 1 degree Celsius.
Well, shouldn't we be controlling our activities and actually be controlling how much light we get from the sun? Like, well, don't you think that we should be focusing on our activities? Because I feel like this is something that I was listening when I was heard about when I was listening to the Mars Colony mission. And they said that the danger with terraforming is that you start looking for alternative planets, which means that you abdicate your duty of taking care of your planet. So
that's an argument. Yeah, the whole Mars thing I kept away from, but that's the idea is that if we simply stop using fossil fuels tomorrow, the planet will still be, because of all the carbon dioxide in the air from 200 years of burning fossil fuels, the planet won't cool. We have to do something else to cool it. And there are only two options. Three options. Direct carbon capture, where you have some huge thing sucking air in and taking out the carbon dioxide, which is nascent technology and it has to be on a huge scale. That's true. There's putting aerosols into the atmosphere, and it's not a huge amount, but everybody worries that that's going to have unknown effects also, because it is the air we breathe, and I think be a bit careful with that. But so experiments with that make sense. And the third option is to cut down the total amount of sunlight coming in before it gets to the atmosphere. So at least you're not messing with the atmosphere. This is a huge venture. You need millions of tons of material to make this sunscreen. And the whole thing has to be the same diameter as the Earth and towards the sun by about a million miles. It wouldn't be a single solid thing. It would probably be lots of little satellites moving around, so that on average, just 1 or 2% of the sunlight is blocked. So it's a fanciful scheme, but it's not crazy in the sense that it demands new physics or anything like that. It's something we could do. The expense is enormous, but again, something to look at. So it might be like a backup plan. If we find that carbon capture doesn't work, and aerosols are very dangerous, which may or may not happen, then you have a third plan to back it up. So yeah, there's a possibility. The place where that million tons or several million tons of material would come from, it's very expensive to bring it from Earth. So the moon or asteroids is the easier place to get it, probably cheaper. So we'll see. I hope it doesn't come to anything so extreme, but it's best to be ready.
That's really interesting to know about. I did not know about the natural sunscreen for Earth. So one of the things that you talked about throughout was the whole idea that in physics, it's not something new. Most of the thing that you really depend on is the investment. Mm-hmm. So my last question is, the best way to become a millionaire in space is to start off as a billionaire. This is evident from the space activities that are planned by Jeff Bezos, Elon Musk, and Richard Branson. Given the recent interest or maybe trend in space exploration, in your opinion, what does the future of asteroid mining entail? I ask this question both from the perspective of innovation and investment.
There have been people who've lost a few $1 million on asteroid mining companies that failed, basically. They both got taken over, but they aren't doing asteroid mining anymore. Short-term way of making money in space is to certainly to work on low Earth orbit applications, and we've already seen tourists go to space just now on the Inspiration 4 mission by SpaceX. The cost is outrageous, of course, now tens of millions of dollars per person. So, but that is a price that could come down, and I think there is a whole bunch of people have expressed interest in going to a new space station that a company called Axiom is building. They will be attaching first to the existing International Space Station, then adding modules until they have a completely self-sufficient station of their own, which will detach, and then they will be taking tourists. And they're into tourism rather than supporting scientists, because Philippe Starck, the famous designer, has designed their interiors, and he only normally deals with 6-star hotels or something like that. So they're obviously looking at a consumer market, and there are other companies who might also do that. So tourism, research. There's a lot to be done there in material properties. In genetic expression, which is different in zero gravity for some reason, which I don't think we really know. There are some ideas. And of course, NASA would love to do more on human health in space, because they want to be able to send people on long missions. So there's a lot of research to be done by multiple agencies. And again, Axiom have said that they have a whole bunch of sovereign actors, they won't name any of them, who have expressed interest in sending their people as scientists to their space station. So there seems to be a market. These very rich corporations and countries basically would have enough money in the near future to start that activity and provide a market for people with space stations and transport systems to low Earth orbit. And third, manufacturing in orbit. And there are a couple of things that I find that one very plausible and one a bit out there, but also in a way plausible. There's a type of optical fiber called Z-blan or Z-blan for your audience, which works in the infrared instead of the optical. It in principle is 10 or 100 times better at conveying information, and the light losses are very low, so that you could have a single cable crossing the Atlantic, for instance, with no repeaters or anything. So the lifetime and the cost would be much lower. And we all know that there is no limit to the internet traffic that's required to send those cat videos around. So it's a great market. And so there are two companies, at least three, I think now. The first one was Made in Space, and they've been experimenting on the International Space Station, and to see if a result done on it that came from a very early parabolic flight, where you get 30 seconds of zero gravity. Okay, people quickly squirted out some of the material from which this is made, and they found that it didn't form little crystals. On Earth, in 1g Earth gravity, you get little crystals forming, and that's exactly what you don't want in an optical fiber, because they reflect light.
Yeah.
And you can see them sparkling, but they don't form in zero gravity. And so if you could make, and these could be very expensive per kilogram or per kilometer optical fibers. So the transport costs up and down would be negligible compared with the money you get for selling it. So this is very promising, and these people have had several rounds of experiments trying to make this a continuous process where you could make kilometers instead of less than a meter, probably to begin with. They want to build up to where you can make spools of this material and bring it back down and make huge profits. That really gets interesting, because then you have an industry that can grow very greatly. These companies might start their own space station or buy another space station from Axiom or whoever. And we can see a big expansion of activity in space. The second one I've mentioned briefly is the idea of 3D printing human organs. Yeah. And we can do that you can print ears now on scaffolding. You can print, I believe, livers, because they're fairly simple. Wow. There's only one type of cell, I think, maybe two. But if you want to build something like a heart, it's very complicated. On the other hand, a heart is worth an awful lot to the person who needs a new heart. Yeah. And so being, of course, coming from America, where healthcare is a business, that you can see that would make a lot of money, potentially. And it's reasonable, because in 1G, you put a cell on top of another cell and it kind of slips and falls down. In 0G, there's no force to pull it down, so it just stays there, is the theory. So there's a company investigating this. I think they have an experiment on the International Space Station too. So I think there's a lot of potential for space to grow as an economic activity and provide profits for people and benefits to people on Earth, because those people who get a new heart will be very pleased. And all those people watching cat videos will be very happy too. So there's a lot of benefit there. And as this activity grows, you'll have more and more people in space and more things happening, and they will need to need bigger supplies of water. And water is one of the things that asteroids and the moon can provide fairly easily. Eventually, they'll also need materials to build new space stations instead of bringing them from Earth. And iron is another one of the things you can get in almost pure nickel iron. Is meteorites. We've seen many of them. If you go to a science museum, you're almost sure to see them. There are asteroids kilometers across that are made of this, and so mining those resources is fairly easy.
Thank you so much for joining us today. I really appreciate the time that you took out to talk to us, and it was lovely talking to you. Is there any parting advice that you would like to give to our audience so that they would get interested in the world of asteroids?
Well, apart from reading my book, of course. Well, there you go. Quick plug. There you go. I think there's a tendency to think of it as purely a realm for engineers and scientists. And that chapter you talked about goes into why you need so many more skills to make this a reality, for economics, business, policy, law, diplomacy, many levels of different types of skills to bring all this together to make it happen. So it's possible to get involved in this, even if you can't solve an equation.
Thank you so much for your time, and I really, really appreciate it.
Well, thank you. Very, very good fun.